Welcome! Given that a lot of people have liked my astronomy calendar for 2016, I thought I would do an equivalent one for space events for 2016. I realised there were a lot of important launches coming up this year, and I thought you might be interested in some of them. So here goes, 2016 in space. There is nothing quite so thrilling after spending years building a payload as to hear that final countdown. 3, 2, 1, ignition, and seeing your payload soar into space. This year we're expecting 67 launches from a variety of space agencies. Nearly half the launches will be coming from the United States. Some from NASA and the Department of Defense, while the majority of them are from US private launchers such as Orbital and SpaceX, launching their own payloads or launching payloads for the US government or for other commercial interests. ESA is launching a steady number of scientific payloads this year. China and India are increasing the number of launches that they are scheduling. The next biggest contributor to the launch schedule is Russia, and many of those are commercial launches for other people, and Japan continues its steady progress of 2 or 3 scientific launches per year. Space technology is now a vital part of the modern global economy and also of national defense. You can see this from the distribution of the purposes of the 67 launches that we have coming up this year. The largest single thing is communications. That's beaming television and radio signals around the world, but also conducting commerce, making your cell phone work and things of that sort. Science makes up a disappointingly small proportion of the launches. Navigation is a growing sector, particularly for things like GPS. I've labelled one sector here technology and maintenance. That's technology proving flights and also care and maintenance of satellite systems, replacing defunct satellites and resupplying the International Space Station with people and consumables. Last sector is military. Now this probably is much bigger than is shown here, but a lot of those launches we know nothing about. Of the 67 launches this year, 14 are space science missions, and I'm going to go over some of them, at least the ones I got information on or have personal knowledge of, to give you some idea of what's coming up. You should remember that these sorts of dates are not like lunar eclipses or conjunctions. They don't occur to the second and will likely change several times through the coming year. So if any of these missions do interest you, note them down in your diary, but keep an eye on the mission website to see if there has been a change in schedule, because almost inevitably there will be. There's also some very interesting milestones coming up for some major space missions that have been operating for a number of years, and I'm going to mention those in passing as well. The first mission to be scheduled to be launched in 2016 is on January 17th. It's the Jason 3 mission. This is actually the 4th in an ongoing series of NASA missions to measure sea level. It has a sophisticated altimeter instrument that will not only measure sea level, but wave height and wind speed. The second mission is called Sentinel 3A. It's an ESA mission, but it is being launched by the Russians. It too is an Earth monitoring mission. It will study sea level rise. It'll be getting measurements of land and ocean temperatures, and also studying ice topography. Also, sometime in January, the Paz satellite will be launched. That's a Spanish satellite, but it too will be launched by the Russians. It is going to be using X-band synthetic aperture radar to image the Earth. This is used for topographic mapping at various resolutions. It monitors motions of the Earth and also land use. It is also widely used in military applications. On February 17th, the Japanese will launch ASTRO-H. It is their flagship high-energy astrophysics mission. Now you'll notice something very interesting about the Japanese system is that they do not name their satellites prior to a successful launch. Once launched successfully, they'll hold a competition amongst the Japanese people to name their satellite. I think this is a rather nice way of doing things, and they did this for both the Yoko and the Hinode missions that I was involved with. This spacecraft carries 4 instruments, a hard X-ray imaging system which operates from 5 to 80 keV, a soft X-ray spectrometer which operates from 0.3 to 12 keV. For those of you not familiar with keV, which stands for kilo electron volts, You can change this into wavelength by dividing that number into 12, and that will give you the number of angstroms. So for example, 0.3 keV is about 40 angstroms. It also carries the soft X-ray imaging system, which will image below 10 keV, and a soft X-ray gamma detector, which will give spectra between 10 and 600 keV, which is very high energy. On the 12th of March, it will be the first anniversary of the magnetospheric multiscale mission. This is 4 spacecraft flying in formation. Their objective is to see how the Earth's magnetic field changes in response to changes in the solar wind. Just a few months ago it started its science mission, so we'll be looking forward to seeing some results from it fairly soon. On the 14th of March, EXOVARS will be launched. This is an ESA mission, but again will be launched by the Russians. It carries 2 sets of instruments. One is on a lander, which will be sampling the Mars's atmosphere for trace gases, and the other is an orbiter, which will get high resolution imaging to choose a landing site for the ESA 2018 lander, and also will act as a relay satellite for that rover. There's a rather sad story associated with EXOVARS. Apparently this mission was supposed to be a collaboration between ESA and NASA. However, after the agreements had been signed and everybody had started work on the program, NASA decided to pull out, leaving ESA high and dry. So ESA decided to work with the Russians on this particular program. This is the origin of many of the other space agencies considering NASA a bossy and unreliable partner, which is a great shame. On March 30th, the Solar Dynamics Observatory will be celebrating its 6th year in orbit. It has been producing marvelous solar images and videos that I've often featured on this channel. The scientific results from this mission have changed the concept of how many different types of solar phenomena work, including how sunspots evolve, how flares occur, how the corona evolves, how you get coronal mass ejections, and so on. It is now observed from the start of solar cycle 24 to well into the decay phase of that cycle, and I am hoping that it will continue to observe all the way through this cycle and hopefully future ones. However, there is a cloud on the horizon. That is because NASA has been cutting funding to do the science. They've spent literally $1 trillion putting this mission in space and are bulking at spending a few $1 million to fund scientists to look at the data. I think this is a complete outrage. On April 14th, Sentinel-1B will be launched. That's again another one of these ESA missions to monitor the Earth. It will be a Russian launch. This time the instrument will be a C-band synthetic aperture imaging device, which will be used to monitor land use, look at sea ice, and also monitor marine traffic, including oil spills. Sometime in early July, the JUNO spacecraft is going to reach Jupiter. Its goal is to map Jupiter's magnetic and gravitational fields, to determine the amount of water in Jupiter's atmosphere, and determine the size of Jupiter's solid core, and also study Jupiter's aurora. Yes, Jupiter has aurora just like the Earth does, and from very much the same source, the Sun. On September 3rd, OSIRIS-REX is going to be launched. This is a particularly exciting mission because it's going to go to an asteroid and return a sample. The asteroid that it's going to rendezvous with is rather unromantically named 101955 Bennu, and it's going to rendezvous with it in 2018. This is a carbonaceous asteroid, and the idea is to study the minerals and the possibility of organic material in the surface structure of the asteroid. The samples will be returned to Earth and studied there. On the 15th of September, WORLDVIEW 4 is being launched. This is a US commercial payload which will give 32 centimeter imaging of the Earth's surface. The images are commercially available and represents a major improvement in the resolution of available Earth imaging. On the 23rd of September, HINODE, a Japanese solar mission, will have been in orbit for 10 years, nearly a whole solar cycle. It carries an optical telescope which gets high-resolution images of the photospheric magnetic fields and their evolution. It has a EUV imaging spectrometer that quantifies conditions in the solar transition region, and a high-resolution X-ray telescope to get images of the corona. The group that I used to run actually built the optical telescope and also made contributions towards the X-ray telescope. On 14 October, GOES-R is going to be launched. This is the new generation of NOAA's primary ongoing series of geosynchronous weather satellites, and it's another one that I had a great deal of involvement with, so I'm particularly proud of this. I helped win the satellite contract for my company, and also a couple of the instruments on board were built by my group. The Advanced Baseline Imager is the main weather instrument. We have a space weather monitoring instrument called the SUVI, the Solar UV Imager, which was built at my group. We also have the Global Lightning Mapper, GLM, which I helped persuade NOAA that we should install on GOES. And that one I'm particularly proud of because that one's going to help save lives, because it's going to monitor lightning around the US and give early warning of tornadoes. So that's the missions that are scheduled so far this year. There'll be others that are not on this schedule that will be launched, and some of these launches will probably slip a bit, possibly even into next year. But when we put a payload on top of a rocket, it certainly flies without wings. But we design those payloads with open eyes. We dream up new ideas to test with these instruments and experiments. And in doing so, we see things that people have never seen before, and understand things in a way that nobody has understood them before. And that's the attraction of working in space science. So until next time, bye for now.